So we have examples here. To give you a numerical examples, we have to work through the actual math step by step using simple numbers instead of abstract symbols. So let's imagine a quantum coin flip. A particle is in a superposition of heads and tails. So you will use numbers to show exactly how the math branches into universe. So example one, the single particle superposition. So let's say our particle starts in a 50-50 superposition. And in quantum mechanics, we use complex numbers, amplitudes to represent probabilities. The probability is the amplitude squared. So let the amplitude for hits be 0.707, which is 1 over square root of 2. And the amplitude for tails also be 0.707. So the wave function psi is written as this one, 0.707, and head cat plus 0.707 tail cat. So the probability of saying head here is 0.707 squared, or 50%. The probability of saying tail is also 50% here. So this is just a standard quantum coin, nothing special yet. So you have example number 2, measuring a device, the tensor product. Now let's bring in measuring device, a machine with a screen that start in a ready state. No, in quantum math, when two systems combine, you multiply their state using a tensor product. So initially, the particle plus device combine the system. So this one is the combination of systems. So we have not measured the quantum system. So the particle interacts with the device. The device is designed so that if the particle is heads, the device shows head onto the screen. If the particle is tails, the device shows T on the screen. So mathematically, the interaction distributes the device state across both probabilities here. So we have the total system here, get 0.707 head. So tensor product with the device here plus 0.707. The on the tail, tensor product with the device showing T here. So this is the numerical split. If you look at the math, there are now two separate branches, each with its own amplitude, 0.707. The device is now in a separate position of showing H and T at the same time. So adding an observer, example number 3, adding an observer here, U. Now let's add you, the human observer, who starts in a state of waiting to see the result. So the math now multiplies in U. The combined wave function of the entire universe, particle plus device plus U, becomes this one. So this is for the particle, this is for the device, and this U. So tensor product plus 0.7 for the particle tail, and tensor product with the device showing T. And you see here T according to your consciousness. Now here's the multiverse math in the plain numbers. So branch 1 heads amplitude is 0.707. You see heads, so the device is 8 here. So in branch 2, the amplitude is 0.707. So you see tails, the device is T. So the math has not collapsed the wave function into one branch. It keeps both branches alive. So why you feel like you see only one, the coherence in numbers? So you might ask if both branches exist, why do I only experience once? So this is where quantum decoherence comes in, and we can show it with numbers using a density matrix grid of numbers that the physicists use to track probabilities. So let's write the density matrix for the two branch system. For a 50-50 superposition, the matrix looks like this. So the top step number here, 0.5, is the probability of hints. This one. Then we have the right number, 0.5, is the probability of things here. So the off diagonal here is the 0.5, represent the quantum interference between the two branches, the ability for them to cross over and affect each others. Now imagine the particle interacts with the environment, air molecules, photons, heat. Mathematically, this interaction add tiny random pieces on the off diagonals. So after a trillion interactions, the off diagonal numbers rapidly averages out to zero. So the density matrix evolves into this one, 0.5, the off diagonals. So the off diagonal numbers are now zero, zero. This means the two branches have become mathematically orthogonal. So they are perpendicular in an infinite dimensional space. They can no longer interfere with each other. So for your perspective, in branch one, you see a 50% chance of heads into a 0% chance of tails. But from the global mathematical wave function, both branches 0.5 and 0.5 still exist, completely independent of each other.